how this form log command is work. Basically, when we have the some basically this command, when we want to extract the some field, some variable, then we can then it's, yes, yeah, there is some mistake now. So in basically in this video we will discuss about the form log commands, how it work when we have some this open form case. So then we can store the some log file. Basically that log file is contain all the field variables or iteration wise. So I'll discuss about that in detail, and how is work, and I'll demonstrate for a case, so then people can understand how it work. Basically this is the this kind of BD in this kind of tutorial. This BD in this video I will discuss the simple one command how is work, then a demo. Who's working who's learning the open form, then is very is very this kind of demonstrator is very helpful for the beginner. Basically this one. Now today just let me start for a one case to demonstrate how this command is work. Now let me open the terminal. So let me know the terminal. Just 1 second. T. So just I am opening this some open. So basically several version of OpenFOAM installed in machine. Now we are selecting the 8. So now see now, and we can use this run command. So then we can go to the directory, run directory. So there is another way to another way to go to this run directory. Basically we can see that where is the run directory is there. Run directory is here. As you can, if you visualize this, then you will get the path of this where is the run directory. And another way to go to the run directory, there is a one environmental variable $foam run. If you press this, then you go you can go to the run directory. So let me see what inside there. No, so today I'll take the one base case from the from the source code. So we have to copy that one case here. So let me go to just press 2 to it. So then you can go you can see the tutorial of the OpenFOAM, or let me visualize that clearly at -l. Just do this 1 degree, so you can see this list wise all the. So now I'm taking the one case for the for demonstration this how this command is work. Form log. So I'm going to do this incompressible, and there is a icoFOAM solver. So some cases are there, and let me see, there are two tutorial cases are given in here. So let me go to the take. So see this case, and we just, and this case we can copy to basically this can copy to the our run directory. Run directory here. How we can copy the directory? The cp -r recursive mode, and just copy to the present directory. So let me see now. As earlier you can see the only the two directories are present in this run directory. Now you can see the three directories are here. One is elbow, another is the this one, and solver. So we have to go to this, which now this is basically incompressible solver. Basically elbow, the flow in through elbow. So I'll show you the in this. So what inside this folder lsc, we can visualize this and this folder what it is. Basically this is standard OpenFOAM basically that is the standard format of the OpenFOAM cases. When we have this, or when we are using the OpenFOAM, it has two, basically it has three directories. Basically one the system directory, another the constant. Basically we have to define the constant properties, and here we have in the system directory we have to define this and schemes, solutions and control. So and when we have to define and field this field variable for the initial conditions. We can see in the field, basically like let me show cd or 0. What is inside the 0? You can see the pressure and velocity, where we can define the what is the pressure and what is the velocity we are considering for this simple present case. So now and there is a two scripts. Where are two scripts are here, where either we have to, there is a two way to run the some simulation. So one, either we can use one by one, and we give the commands in interactive mode, and another we have the another option, we have the scripting kind of thing. So we can prepare the script, then we have to run at a time. We can run the script at a time, so all the command will be executed sequentially. Like we can see what inside the all commands run in this present tutorial. See in the present tutorial what it is, what inside this. Basically in the present tutorial, the one is the mesh file, which is mesh file. This is the another version. Mesh file is as we just one sec, I'll show you. This mesh file is given here. So this mesh file, there is a several way to create the mesh file. There are some third-party softwares also, and Fluent and like Fluent and Influent. There is some direct version. There are so many tools. We are not going to discuss about them here. So now like we have also OpenFOAM. There the block mesh and Snappy has mesh. So it's a very good tool to create the mesh. So now in this tutorial already the mesh file is created by somebody, and is and we are using this. How we can use this? So now like I can show what inside this. So there is a command fluent mesh to foam. Basically here fluent mesh, it can be imported into the foam, into the OpenFOAM. So this is the command we have to execute. So and another command is this run. Basically run is the solver name. Basically here we are using icoFOAM, so that is the solver. So another two more command is executing this script file. Basically what it is, where this it will convert the OpenFOAM mesh to the fluent. So we can use in the fluent. So another another command we are using here, from data to fluent. So what it is, it will convert the all OpenFOAM data into the which we can import into the fluent. So these are the four commands we are going to execute it here in this script. So now nothing else, just either we can go one by one. So but I'm executing this script. Run. So just run. Yeah, this, as we can see, this one, and this is the basically this for the 10 seconds the simulation is get over. Now whatever command whatever we have executed. So if you want to visualize, then you can show the log file for like fluent. Just one second. Fluent form. So you can see what we have executed here, this command here. So you can see all the listed. So yeah, so and these all the same thing. And what we have done here, then we have executed this icoFOAM. So we can visualize this log.icoFOAM. So we can see our simulation run history, and like So at see, it will basically start from 0, right? So there is a whatever iteration is happened, the all that stored in this log file. So basically in this log file we have field variable is stored here: pressure, velocity, and pressure. And another current number also is stored here. But see, and we want to see how these variable like pressure P and this velocity is changing with respect to this time. So that's what we have this command. What it does basically: foam log, this command. If we what thing will be exported from this log file. Just if you want to see, then you can visualize list, and that's the log file. What is the log file of that solver? This one. This you can, if you execute this command, you can see what will be the executed execute yes, export from this log file. So these are the you can see clock time, and this and pressure, all that time respect, basically 0 time, 1 time, 0 time, 1 2 3 time, how this value is changing. So if you want to see, then just you can and just one more thing, ls you can see there is a only the one directory, this constant, this time directories and constant and system. So if you want to execute this command, so yeah, all the field all the these are the exported into one directory. Another one directory is created that we call the log directory. What is inside the log directory? We can visualize cd logs. What is this? What are the value? What are the things in this? At C, we can see we have listed here all the thing is exported so into the xy data. XY data. Now this XY data, if you have the XY data, then you can this XY data. Now you can plot in you by using any application in the XY diagram. Let me show one file. How this. Let me just show one file here, so you will get so this. So you can see the how this velocities change with respect to time. So basically this is the velocity changes with respect to time. So you can plot this data and in the XY diagram by using any application like LibreOffice, and you can use some tool, MATLAB, any other tool, whatever you want. So just basically this will data you will get it. That's the that is the more work to extract the xy data, this command. Just one second. Yes, this command now. And then we have seen the two commands. So basically this is the two command. This the where this form data, and you can see cd fluent. So this ls, that data basically when we do this form, just one second, this form mass to fluent, then it will generate this file. So it will be used in the another software like fluent software. So and when we execute this command, this form data to fluent, so it will all the data, like we have the OpenFOAM present case. So it had the 0 time directory, 1 2 3, all the time directory. It contains all field variables. So these variable we can, if we want to use in another third party, another software, so we have to extract that data, extract on their format. So then here we have executed this command. So all the data corresponding this time directory is converted into the dat format. So if that for this data can be visualized in the fluent when we use the fluent. But our motto is not here. Just I explain whatever inside in this tutorial case. Now our motto only this to how this log how this foam foamLog command work. If you want to take some help, just type help, though it will talk about what is work, all the how is work, all about this command. So, and one more thing I want to describe here, like just we can see this just one more thing which is very important here, log. So log.icoFOAM, this file, and we can see here there are only we have the velocity and pressure variables are here, because another very, if you want to write another thing here, then we have to go to the solver. So in solver there is a create fields, there is a file create field plus solver file. So I'll explain this, just you will get some more info. So that's like we have this just this case, just let me clear the screen, and I want to show this how this data is written. Just solve. Basically, if you use this solve, so you will get the solver. Basically that is the environmental variable set. So now just we can do this, and this icoFOAM, we have to go to the icoFOAM cd incompressible and icoFOAM, this one. And what is inside this, what is inside this solver? Basically we have the two files here. One is the solver icoFOAM.c, and another is the header file, which create field, which all the fields variables are listed. Just let me show what is inside in the create fields. Just let me open this file. As you can see, only in that log file, like I told you about this, what inside this is in this file only the pressure and velocity fields. Now see, like we have the create we have defined the create fields here. We have not like we have the another properties, no, that like transport properties and yes, and velocity and field variables, like we have defined the field variables here, like pressure or pressure, volume, scalar, field, pressure and velocity. As mentioned, as you can see here, we have mentioned here this pressure is, it will write in the log file. It must it will read, because we have to write, and it will read for the each iteration. Yeah, and another is the u field velocity. Yeah, we have both. We have this. If you want to write more another another things, like if you want to see this transport properties not written in the file, you have to change this, like in this fashion. Must this one auto, you if you this auto write, it will write in that log file. So this is for advanced, when we have somebody is doing something in for the beginner. Basically this now I want to see this this how, what is basically we have done how this command is work, but what we have solved in this problem. Like we can see, just we can just we can execute paraFOAM, then we can see what in this. So, and yeah, basically this is elbow 2D case, basically 2D case. One we have the input velocity inlet, and another is outlet. So we can see here how, see the velocity, just one second, this one, like this basically this elbow case. Just let me visualize in more clear way. Get, yes. Now suppose let's see, if you want to just one second, just one second. Yes, and you can see the velocity. You can see the velocity control plot here, how the velocity is changing here. So at different time you can run. So basically that is the case. You can find the, if you can export your in your own way. So just I demonstrate, basically my purpose to demonstrate this command, how this foamLog work. Yes, now we have, now if you want if you want to, if you want me, if you want for me to explore things, then you can write your comment and I explain, but everything we can't take together, we can't describe together, we can't demonstrate together, we have to go one by one. Like I have covered some few more commands in previous video. You, yeah, that's it. I hope now you understand, some people are understand form law, law command house work. So that's it for today's demonstration. Thank you for watching.